Today's lesson is on ellipses. An ellipse is a lot like a circle except for it is oval in shape. And so we're going to see some of the same things that we've done with a parabola. And for one thing, we'll see that our center is still going to be at 0, 0, just like we had with our parabola. Some things will be very different. So let me label some things for you so you can find these things when we're graphing. In this ellipse that I've drawn, the long distance that goes across, all the way across, the longest end is called the major axis. And half of that is where you're going to find the length for A, which you're going to see up here in our formula. And the other direction is called the minor axis. And half of that distance is going to be B, which you'll see up here in our formula. X is going to stay X, and Y will stay Y, and so the X squared and the Y squared are not going to change, and also they always have to be equal to 1. Every ellipse has to be equal to 1. So when we're writing an equation for an ellipse, the only things we need to find are A and B, and we can use the A and the B to find the points to create our ellipse. So this ellipse is horizontal because it goes sideways, as you can see. And so the X squared and the A squared are in the same fraction. If I switch it and put the X squared with the B squared and the Y squared with the A squared, then you can tell that this now is a vertical ellipse. So this time the major axis goes this direction, so my length of A would be one half of this, and then the minor axis goes this direction, which would be half of that would be the length of B, which is going to be there. So graphing and writing the equations for an ellipse is actually a very simple thing. Don't forget that all of these will have a center of 0, 0, which makes our formula a little bit easier. So we're either going to have X squared over B squared plus Y squared over A squared, or it will be flip-flopped as we go through to graph some of these. So let me show you what this looks like. Oh, also one other thing is that just like with a parabola, an ellipse has a focus, and that focus will be C. And when it comes time for us to find the focus, we're going to use this formula here, C squared equals A squared minus B squared. And A squared will always be the bigger denominator. So whichever denominator is bigger, that's going to be A squared. Okay, so let's take a look at an example. If I give you X squared over 25 plus Y squared over 4, then this is A squared because it's the bigger denominator. This is B squared because it's the smaller denominator. The X is on top of the A, and so that's going to tell me that this is a horizontal ellipse. Now it's going to be easier to see here in just a moment, because if A squared is 25, then that means A itself is just 5, because 5 squared would give us 25. And B squared is 4, so that means B is 2, because if B squared is 4, then the square root of 4 is 2. To graph this, we always start at 0, 0, and then we're going to go 5 units and we're going to go 2 units, and here's how you know. The 5 is under the X, so in the X direction I'm going to go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And I will do my best to make this as even as I can. And then in the B direction, which will be with Y, I'm going to go up 2 places and down 2 places. And then when I connect those 4 dots like this, I have kind of a crooked, misshapen one, but it is an ellipse. That's all you have to do to graph an ellipse. It's really awesome. It's really simple. To graph the ellipse, we don't even need to find the focus, but if we needed to find the focus, we need to find C. So it would be C squared equals A squared minus B squared. Well, my A squared was 25, and my b squared was 4, so my c squared is 21, which means my c is the square root of 21. And we don't need that information right now for any particular purpose, but it's nice to know, and we'll come back and look at that again some more. The square root of 21 is somewhere between 4 and 5, so it means that my c would actually be somewhere out here and out over here. Okay. All right, next example. To graph this, first of all, this has to be b squared this time because it's the smaller denominator. And this has to be a squared because it is the bigger denominator. So this time my b is under the x and a is under the y. So since b squared is 9, b is 3. So in the x direction, I'm going to start from my center of 0, if I can get my dot there, and I'm going to go in the x direction 3 units. 1, 2, 3, 1, 2, 3, put a dot there, put a dot there, maybe. Okay, and then for a squared being 16, that means a is 4, and since a is under the y, we're going to go 4 up, put a dot, 4 down, put a dot, connect my dots to the best of my ability with my squiggly pen, and there's my vertical ellipse. That's all it takes to graph it. It's just that simple. Okay, what if we're not graphing it? What if we're given information, and with that information we have to, I'm sorry. Okay, as I was saying, the vertex here is going to be 3, 0, and the co-vertex is going to be 0, 2. This is the information that's been given to us. Now, we haven't really talked about vertex and co-vertex, but the vertex is the bigger number, and so it's going to be A, and the co-vertex is the smaller number, so it's going to be B. If my A is 3, that means A squared is going to be 9. If my B is 2, that means B squared is going to be 4. So now when I go to write the equation, I'm going to write, I need to know what goes with x squared and what goes with y squared. And remember, all of these equations always are going to equal to 1. So how do I know? Well, when you look at the a up here, the bigger number, it's in the x position of the coordinates. And when you look at the b, this number is in the y position of the coordinates. So a goes with x, so that means 9 goes with x squared, and b goes with y, so that means 4 goes with y squared, and just like that, I've written the equation. It's just that simple, not so bad. Now, the last type of problem you're going to see, you are actually going to be given the vertex, and you're going to be given the focus. Now remember, the focus is C. My equations are made up of a squared and b squared, so we have to use the C to find the rest of the information. So let's start with what we've got. The vertex is always going to be A, and then the focus is going to be C, so a squared is 4, b squared we don't know, that's a question mark, and c squared would be whatever you get when you take 2 square roots of 3 and you square it. Okay? Well, when you square that, it's actually going to be 4, because 2 squared is 4, and the square root of 3 squared is 3, so 4 times 3 is 12. So c squared is 12. 2 times the square root of 3 squared is going to be 12. So remember, the formula was c squared equals a squared minus b squared. And we need to find the b squared. So c squared is 12, a squared is 4, we don't know b squared, that's what we're trying to find. So I'm going to subtract 4. Now I have 8 equals, I did something wrong. I did something big wrong. Okay, let me back this up. Okay, I don't know how this is going to look in the recording, but I've kind of backed up some of my stuff, and we're going to try this again. The vertex is A, and the focus is C. A squared would be 4 squared, which is 16. B squared we do not know. That's a question mark. C squared is going to be 2 times the square root of 3 squared, which is going to be 4 times 3, which is going to be 12. The 4 comes from 2 squared. The 3 comes from the square root of 3 squared. Now, since we know that C squared is going to be A squared minus B squared, C squared is 12, A squared is 16, we don't know B squared. Subtract 16 from both sides, which is going to give me negative 4 equals negative B squared. So if I divide both sides by negative 1, they both become positive. And the square root of 4, if B squared is 4, then B is 2. So using that information, if I know, well, actually I don't even need to know B, I just need to know B squared, didn't I? Because when I put it in my formula, I needed A squared, which was 16, and then a B squared, which is 4. Okay, so now, where's A going to go? A is 4, which is in the y position here. So when I make my equation, the 16 is going to be under the y. And so that means that the 4 that goes with the b squared will be under the x. So when I write this out, let me make myself some space and I'll write this for you. Let's try to find a, okay. So I'm going to have x squared over something plus y squared over something equals 1. And the x squared part is going to be 4, and the y squared part is going to be 16. And I'll say one more time, the 16 is a squared, and a is in the y position. So 16 goes under the y, which means b has to go under, or b squared actually has to go under the x squared part. And that's the equation. The problems where you have a vertex and a focus will be the most difficult types of these problems because all of the rest of them are so simple. But this is just the process that you go through. You just have to find either you either have to find what b squared is or you have to find out what a squared is, but you're still going to plug it into the same formula. And I probably confused you, so be sure and ask me about this if you have questions. All right, the assignment for this lesson is page 140 through 141. It's 1 through 12 all. I apologize for any glitches in my recording. I had to pause a few times and answer the door, so have a great day.